Good morning, everyone. Thanks for attending our malware analysis webinar. My name is Nathan Swaim. I'm the president of ANRC, and one of my goals this year was to increase our public awareness into all the research we've been working on in the cybersecurity arena. So let us know if you'd like to be on our webinar mailing list. We're going to be doing more of these. We've done about 3 already. One was in mobile forensics. We had another one on cell tower tracking for forensics examiners doing court cases. And after we reviewed the webinar last night, we decided that there's definitely a lot more content we could have covered in this short amount of time. So we're thinking about making a malware analysis series if you'd like to be involved in that, so that we can kind of cover more specific topics one at a time over a period of time to make it a little bit more thorough. So the goal of this webinar is to create awareness about the basics of performing malware analysis. And our target audience is information security professionals, forensics examiners, and just general users who want to learn and how to get started in this malware analysis field. So our speaker today is Jimmy Wiley, and Jimmy is a subject matter expert in the field of malware analysis. He's been involved in reverse engineering for over a decade. So I think you'll be very interested to hear his experiences and his approach as well to malware analysis in general. At this time, I'd like to introduce Jimmy and let him get started. Go ahead and take it away, Jimmy.
Hi, everyone. Like Nathan said, I'm a malware analyst, reverse engineer, doing all sorts of research for ANRC. Just going to go ahead and get started because there is a lot of material here. So we're going to talk about a few things, just some prevalent, sort of malware that's making the headlines right now, and just sort of the basics of what malware is, along with the process and how to set up your environment and different tools before we go ahead and get into the demos. So these are some things that just happened earlier this month and sometime last month. Got 2 new point-of-sale malware families that were discovered. You have the animals in the APT farm, which is a malware framework that was found targeting Syria via some water hole attacks. And then you also have this latest headline that was related to Stuxnet and Flame and stuff called Equation Group. Has all sorts of capabilities, very, very large architecture that includes things like infecting hardware firmware. So it's pretty obvious right now that, just in general over the past, we've been seeing more and more of these reports, and they seem to come out more frequently. It's just getting harder and harder to keep up. So malware is basically a bad program, right? So we have a formal, semi-formal definition here. It's a program or set of instructions designed to infiltrate or potentially corrupt a device and allow manipulation of the system without users' consent. Maybe better way to look at it, maybe a higher level way to look at it is malware is just regular computer software. It doesn't differ at a lower level from good software. The idea here is you really got to figure out what the intent of the software is to decide whether that's good or bad. If you think about something like an installer for a piece of software, a lot of times it can do some of the same things that malware would do when it installs itself. And you just need to figure out if it's something you actually want on your network. So here's some things that the main malware can do once it's running. It can just render your system inoperable by deleting sensitive files. It can just reformat the drive, similar to the Shamoon attack that happened at Aramco. It can also just spy on you, grabbing video and audio from camera or microphone. Just recently saw a presentation, I think that came out last year, I believe it was at Usenix, where someone figured out how to turn on the Apple microphone without the LED turning on. And it could also just steal valuable intellectual property, financial documents, sensitive info, just basically anything that's on your computer, anything that you have access to. So malware analysis is basically the way that antivirus vendors and security researchers sort of combat this problem. It's the process by which they figure out how malicious software works, what it does, what it's after, how it stays on your system, how it communicates back to the sort of command and control server, and also. Related is also doing things like correlation, trying to correlate different malware samples together, relate them back to certain threat actors, so they can sort of figure out, just by looking at maybe what malware is targeting, they might be able to sort of intuit who might be after that information. So generally speaking, we have two broad categories of analysis. There's a static analysis and dynamic analysis. Static analysis is basically any analysis you conduct on the dead disk file. As long as the malware is not executing, it's technically considered static analysis. Dynamic analysis is the kinds of analysis you do when you run the malware. So we're going to go through each four of these different types. But this presentation is mainly going to focus on the beginnings of behavioral analysis because it's the easiest one to grasp when you're first starting out. So information gathering, it's really basic stuff. You can think of it almost as a metadata viewing, and some content. You can look at strings that could reveal some handy stuff. Things like I've seen really arrogant things in malware where you look at the strings in the malware and you'll have an author string, written by or coded by Hacksaw or some nonsense like that. You could also hash the file and use it to compare to like whitelists and things like that. You could run YAR as signatures. But the idea here is just to collect some extra metadata. It's really quick. It shouldn't take more than 5 or 10 minutes, and then you can use that to sort of relate or put in a report or whatever. Some of the things that could cause some problems with information gathering. Certain strings are not going to be visible. A lot of malware uses encryption or obfuscation. And when samples are packed, which basically just means obfuscated so that the execution isn't so obvious when you look at it statically, you won't see libraries and APIs that this piece of malware depends on. So if you're not familiar, APIs are just sort of the system call interface for Windows. If you need to create a file in Windows, you call a particular function and that interfaces with the OS so that the file actually gets created. Generally, with regular software, you can see all the APIs and DLLs they're going to be used when it executes. But when samples are packed, you don't necessarily see all that information. Disassembly translates the machine code, which is sort of the native language that your processor understands, into a human-readable assembly code. This technique has several advantages. One of which is that you can see the entire view of what the malware could possibly do. So you'll see the decision structure, the different paths it can take, and sort of follow each of them to figure out what's going on. And it also helps you sort of map out the malware so you know what to focus on when you're doing your dynamic analysis. The common tools for this technique tends to be IDA Pro. That seems to be the industry standard, but if you're doing some Mac analysis, OS X analysis, Hopper is also a very good alternative. Hopper will also work on Windows malware, but I haven't found it to be as good as IDA Pro. And you also have a couple libraries if you're designing malware analysis tools, DieStorm and Capstone. Capstone is particularly interesting because it actually works in multiple architectures, and it's on the line. You can just upload code and it's free. So this technique can be a little bit harder because you need to know assembly to do it. So at least when you're starting out, just looking at things statically can be very difficult. You don't have any visible output. So you can see later on when you do debugging, when you're analyzing malware, you're not sure about a particular section of code, you might be able to see exactly what its effect on the system is and sort of intuit what those things are. But when you look at things statically, you just have to know what it is. And then you have things like obfuscation, polymorphism, packing, and encryption that can just make your life hell. And generally speaking, you're going to have to do some dynamic analysis stuff to sort of get around those things. So debugging is sort of like static analysis in that you will see the assembly code, and then you get to run it step by step and control the execution. So this is really nice because you can see what's happening as you're viewing the code, and you can also modify things. So if a piece of malware is sending something out on the network, right before it sends things out, you can actually pause the execution and look at the contents of memory it's about to send. So you can actually grab the packet or grab the buffer or file or whatever it is it's about to send. And and take a look at it. You can also modify it to see how maybe how it would react, things like that. You can also force different code branches to execute when you see decisions. Because if you just run the malware straight, it's just going to go down one code path. So if you want to see how some other things work, you can just flip a bit, go down this other branch, and see what's going on. Also, debugging helps you to unpack and decrypt malware manually. So you have a few debuggers you can use. Ollie Debug and Immunity Debugger seem to be the most popular. IDA also has its own debugger built in that does remote debugging, so you can set it up on a VM and all sorts of neat stuff. They'll connect back to your analysis machine, so you're not necessarily running malware on the machine you're analyzing on. And then you have WinDebug, which you can use for user-level malware analysis, but most people tend to use it for kernel-level debugging. So the problems with debugging, not really problems, just limitations, something to keep in mind. You need to know how to read assembly, because it will show you the assembly code. And you also need to be aware of all the different anti-debugging tricks. Malware can do all sorts of things to crash the debugger, detect that it's there, execute code that you're not necessarily seeing on screen, so just sort of hidden control paths. And there are definitely things you need to be able to look out for before you start, otherwise you're just not going to get a full picture of what's going on. So behavioral analysis, and this is kind of what we're going to talk about for the rest of the session. You're running the malware, but you're not actually looking at the code. You can think of it as more like an observation, maybe poking a bear with a stick. So you run the malware, and these system monitoring tools will look at how the malware affects the operating system. So we're looking at things like files created, access deleted, your registry keys, which ones were written, what IP addresses or domains got contacted, you've got mutexes that were created, and things like that. And so these system monitoring tools basically hook the OS for you and then show you all the different changes that are going on without actually ever touching the malware. So the malware just kind of runs. And some tools you can use, and some of these we're going to cover later. API Monitor, the sysinternal suite, Wireshark, and Cuckoo. Cuckoo is sort of an automated version of behavioral analysis. I think I mentioned this later, but a lot of people like to use Cuckoo in their organization, and it's a good tool to use if you understand it. But it's really good to know sort of manual process in case this thing breaks, and also just for verification purposes, you're going to want to know, how this thing actually got its data. Some limitations of behavioral analysis: if the malware encrypts its network encrypts its network traffic using some kind of custom algorithm, you're still not going to be able to get good PCAPs. You can only see the result of one path of execution, unless maybe you change your environment. And so that can be an issue. And then, conditional code might not be executed, which is sort of the same thing. Basically what I mean is if you run a piece of malware and say a particular registry key isn't set, the malware is going to act differently than if it is set. And so that's something to keep in mind. You really need to intuit with the different environments and conditions that are needed to sort of massage the malware into doing different things so you can get a very good trace of what's going on. So the malware triage is sort of the actual initial analysis process. So this is going to use a combination of a couple of the techniques we just talked about. And the idea here is that you have about an hour, and you need to judge whether or not a suspicious file is malicious or not, and then just retrieve some important information about it. Important thing to know about triage is because you're only really spending an hour and you can't really be too thorough, it only provides an initial picture of the file. And generally speaking, it lacks some completeness. But the idea here is to get good enough information, or enough information to make a decision as to whether or not this is something you need to pursue further. You can analyze malware in 10 minutes and get decent network signatures out of it, so that you can sort of put a stopgap into your IDS or something to start blocking traffic from that particular sample. Like I mentioned before, this sort of thing can be automated, but you should be aware of the manual process. And so this is sort of the basic dynamic behavioral analysis process. You need to get this initial autopsy section. This is basically where you look at the file, you figure out what it is. Maybe you do some the information gathering, looking at hashes and signatures. Then we need to sort of set up the tools, execute the malware, we collect everything, all the different logs, and all the different tools set up, and sort of review it and make sure you've got everything you need. Otherwise, you just sort of run it again. And so, what sort of things are we actually looking for when we analyze malware? There's a pretty big list. There's probably even more than this, but this is just sort of what I can come up with. Things like the file size, the type, the hash, these are very specific metadata points that can help you correlate back to maybe known malware. Whether or not it's packed is important. Important strings like we talked about. A lot of this stuff we sort of covered, files that are access to registries, whether or not it creates another process, possibly a service on the box, mutexes, what sort of persistence mechanisms does it use, how does it allow itself to stay on the system. Some malware, will just hook itself into the registry or put itself in the startup folder. Other malware doesn't care about being persistent because maybe it's targeted at servers that stay up for a very long time, so it's not worried about reboots and shutdowns. And at a higher level, you're really trying to get, an okay picture of what this malware does, what is it after, what's it interested in, and sort of how will it affect the system? Does it cause any system degradation? How much will it really affect your sort of operating posture? And then, of course, is this thing actually malware? And so the second step here is sort of your tool setup and startup. So we really need to cover how we're going to set up an environment for malware analysis and sort of what you need to get ready before you even start doing this kind of work. So the first thing is you just need a safe environment to analyze the malware. When you're doing this by yourself, or maybe in a research context, you tend to just do this on one machine. So the common approach is just to use VMware to isolate the OS you're executing the malware on from your host. So things like VMware, VirtualBox, and KVM will work. But just be aware that even this virtualization is not 100% safe. You kind of want to use a computer you don't mind losing for a while, or have a backup computer, because there is malware that can break out of these VMs and infect your system. And as far as your regular setup, you kind of want two virtual machines to do this, one for analysis and maybe one for services, things like web server, DNS, and things just to sort of emulate the network traffic. It's not required. In a lot of cases, you can get away with one VM, but there are certain situations where using two virtual machines is a good idea. So your analysis VM, this is going to be the VM that you actually execute the malware on. So ideally, you have the malware in this cage, and you have all your different analysis tools that are spying on it inside of this, inside the cage, and then you have your boundary. A VMware and VirtualBox would sit on to protect your host OS, which can be basically anything. I would recommend that your host OS, so the main OS of your system is different than the main type of malware you're analyzing. So I tend to analyze Windows malware, so I prefer my host OS to be OS X or Linux. And this is just to further mitigate, the off chance that a piece of malware breaks out of my virtual machine and tries to infect my system. Something like a multi-OS or sort of a multi-OS malware that can break out of the VM and then infect any OS it happens to be on is very unlikely, although I have seen some proof of concepts before. So some precautions to take. You want to make sure that your virtual machine is sealed off from your network and it doesn't have access to the actual internet unless you know what you're doing and you want the malware to communicate out to the internet to maybe download a stage 2. You never want to take any executable or DLL out of your VM because you don't know if it actually got infected. You should never shut down your VM. Instead, you want to restore your snapshot. This is just you basically snapshot your VM once you have everything set up to analyze, and then you want to save that snapshot. And the reason you always restore is in case you run some malware that installs some persistence mechanism to start on boot. When you shut down that system, the malware will still be there. You might turn it off, walk away, come back to work the next day, start up your VM, and then you have this piece of malware that's already executing. So when you go to analyze your new sample, the data for that new sample is going to get polluted by the data from the old one that you accidentally left there. And so this is just a really good, it's just good practice. You also want to make sure there are no shares in the network with write access. So this includes a few things, especially with VMware. Things like shared folders you want to disable, copy paste functionality, drag and drop functionality. These are all things that could potentially just holes inside of that barrier you're trying to create when you analyze your malware. And like I said before, in general, you want your host OS to be different than the virtual machine OS. So once you have your environment set up, we need a few tools to actually get started. I'm just going to cover like a very small list of tools for behavioral analysis. There are hundreds that you could download. And just keep in mind that different pieces of malware have different requirements, so you might need different tools, and also people have different preferences. The analysis process, although people try to formalize it, still has there's a little piece of it that tends to be kind of fuzzy, and everyone likes to do things, their way. So just take this more as a suggestion of sorts of tools to look at, but don't consider it absolute or, the only way to do this. So the sysinternals tool suite is a bundle of OS sysadmin tools that was developed by Mark Russinovich and others. If you don't know, Mark Russinovich is one of the co-authors of the Windows Internals book. And so the idea here was to provide this list of tools that sysadmins could use to sort of debug problems. It turns out that the sorts of things they would monitor to debug problems are also the sorts of things we like to look at for malware. So you got a few in there that are very helpful. The first three, Procmon, Process Explorer, and TCP View, we'll cover, as well as strings. And then there's also the auto runs tool that I wanted to mention. Auto runs, you can run, you run a system and it basically displays all the software that's set to run on boot. So it can be helpful for looking at some common persistence mechanisms, especially when you're first starting out and you may not necessarily know exactly which registry keys to look at. And you can download this tool suite at the link there, sysinternals.com. So the first one is Process Explorer. It's an advanced task manager that organizes your processes by tree, so you can see the parent and child processes. You can view loaded DLLs and other process properties, where the executable is actually running from. You can view the strings in the process. It'll even tell you whether or not it thinks the process is packed. It's just helpful for monitoring the malware execution, making sure it's running, whether or not it starts some other processes, whether or not it just shuts down right away. It's just good. It's all color-coded, so when the malware starts or process starts, it'll be like this dark purple, and then when it shuts down, it turns red. So it's very easy to spot sort of activity that's happening on your system. You have Process Monitor, which is basically an event logger, and it only logs certain kinds of events. In general, it monitors registry, file, network, and process or thread events. Generally, you want to use Process Monitor to analyze registry and file activity, and some process activity, but that's not necessarily as important. The network piece can act differently depending on the version. Depending on the OS version, it's not necessarily as reliable. So you're going to want to use a different tool like TCP View or something if you're really trying to look at network activity. But generally, what we're going to use Process Monitor for is just to look for read and writes to certain files and read and writes to certain registry keys. And it'll also log everything on your system, so there's this filtering mechanism that you can use that I'll show you later, so you can just sort of focus on the processes you're interested in. TCP View, if you're familiar with the tool, it's kind of like a simple netstat for Windows. It displays all the sort of TCP and UDP connections and associates them with their owning process. It'll show you sort of the local or remote addresses, the ports they're connecting to, and it lets you know the status of the connection. So whether or not it's just, a piece of malware might just start up and just start listening, so you'll be able to see that here, or you can even see the socket get established and communicate out. So it's a pretty handy tool, especially if you run a piece of malware and it does a bunch of crazy things that you can't really necessarily keep up with. But you see Wireshark or some other tool, you see some network activity, but you don't know which process it connects out on. You can go look it up in TCP View. Wireshark is the basically standard for network analysis. It's basically the most common thing for analyzing and monitoring traffic. So the way Wireshark works is it basically, think of it as it attaches to your network card, and it shows you everything on your network that your network card can see when you're running in promiscuous mode. If you use Wireshark in a VM, it means you'll basically see everything that communicates out of your VM. If you use Wireshark on hardware, depending on your network card, you get certain kinds of traffic. So you really have to be aware of what you're using this with. But it's a great tool for this kind of thing. It also has built-in logic for analyzing a ton of protocols. You can see in the screenshot there, we've got DNS, TCP, TLS. You can also look at HTTP traffic. And it also will sort of sessionize it for you or collect it all into one stream. So if you have a communication between a client and a server, you can view it all as one communication in sort of a human-readable format so you can see what was going on. It also has a filtering capability that can be handy, especially when you have a very noisy network. So it's just some filters over here on the right. Simple IP address filtering. You can filter by port number, application protocols, and you can even get into details of the application protocols. So that very last one is basically a filter saying, show me all the HTTP GET requests. So it's a very I don't want to say in-depth language, but it's a very handy resource to understand. So since we have, generally speaking, your VM is going to be sealed off from the internet, and so what that means is that you don't have access to sort of the very common things that we use the internet like DNS. So malware doesn't just connect out to IP addresses, it might just look up some domain, like in this screenshot, nastymalware.com, in order to figure out where it wants to connect to send information or get further instruction. Well, when you seal off the internet, you don't have access to DNS servers. And just in case you're not aware of what DNS is, it's basically the telephone book for the internet. When you look up if you look up someone's name in a telephone book, you get their phone number. In the same way, your web browser looks up the domain name and gets the IP address to connect to. So we need some way to fake this service in case malware has to connect out to this domain. The reason being, if it can't get out to that domain, it won't actually send the actual traffic that we're going to be interested in. So a PATI DNS is sort of like a one-click GUI system for just starting a DNS server and having it reply with whichever IP you want. And in the second demo that I'm going to give, I'll show you how to do this. But basically, you give it the IP address of whatever VM happens to have the services or listeners and things that you want the malware to communicate with so you can capture the traffic. Now, you have a few other tools you might want to look at that I'm not going to get into in this presentation. There's Redshot, which will take a snapshot of your registry before you run the malware, snapshot afterwards, and then you can do a diff on them to see what's changed. CaptureBat will install basically a kernel-level monitor that shows you all the events on the system, registry and files and network activity. API Monitor will give you an API trace by process, so you can see exactly what system calls it makes to Windows. INetSim will simulate a variety of network services, so you can just run INetSim on like a services VM, and it'll emulate things like an SSH server, FTP, HTTP. And we have Volatility, which is a little bit advanced, but it can come in handy when you're doing analysis. Volatility is basically a memory analysis tool suite. So what you do is you'd run your VM and you'd save the when you start your VM, you save the memory snapshot at that point, run the malware, and then save the memory snapshot afterwards. And then you can use Volatility to sort of compare what memory looked like before and after. So you can look for things like loaded kernel modules and things like that. So Volatility can give you some awareness outside of the VM while the malware is not running, so you have some guarantees that your tools aren't necessarily being messed with. Process Hacker is similar to Process Explorer. It's just another way to view your processes. Some people prefer it over Process Explorer. It's really a matter of preference, but it allows you to do the same kinds of things. You get to see the process tree. You can look at various properties, DLLs, handles, and things that the process has access to. It's a pretty handy tool. All right, so we're going to go ahead and I'm going to show you the first video here. Like Nathan said, I've recorded 2 screencasts here with audio. I'm going to talk through them here live, but then afterwards we're going to share some links on YouTube so that you can go ahead and walk through this video sort of at your own pace. if you do get confused by anything or anything like that, feel free to ask a question. But like I said, the video will be available for you to watch. And I guess before we get started, do you have any questions, Nathan?
Nope, no, so far everybody's pretty quiet.
Okay. All right. So the basic scenario here that we're going to cover is we have this logon.exe suspicious executable, and we're just going to do some basic things to figure out what's going on. So the first thing we're going to do is set up our tools. So we're going to run Process Explorer as an administrator. You have to remember to do that because if you don't run as an administrator, it might necessarily have the right privilege to access certain processes. So if you look on the right, you just have your sort of top window with your process tree. You're going to want to show the lower pane using the View menu, and that allows you to see a couple properties about each process you click on. So if I click on Process Explorer here, it'll show me the handles available. Just basically everything that's opened up for access. So you have files, registry keys, you have mutexes and things like that. If you hit Control D on your keyboard, it'll show you the DLLs, which are basically all the libraries that are loaded in its address space. So you're going to use that to look for certain injections and things like that. So, and then you can just hit Control H to go back. So we're basically just going to use Process Explorer here to monitor our malware's execution, make sure it starts, shuts down, or if it shuts down, things like that. We can go ahead and fast forward this just a little bit. We're just gonna show you process monitor here. I think it's rewinding for some reason. There we go. So this is a basic output here. You just have this really dense log that's running. We're going to sort of get back to that later, but you can see you have sort of the timeline on the left of all the events. You have the process name that created the event, and the type of event, and then you have some other details on the right, sort of the path, and further out, if you expand the window, you'll see things like whether or not the call was successful, things like that. Now the next tool we're gonna open up is TCP view. I'm just gonna move that forward just a little bit and get to that. So here you go. So TCP view, like I said before, we're just gonna leave running to monitor whether or not the malware actually communicates out. So you can see you've got the process names on the left, the PID, the protocol, local address. Later on, when things are actually running, you can see sent packets and received packets and things like that. But this is basically what we're going to use for this demo to see if our malware suspicious binary is actually connecting out. So we're going to go ahead and run the malware. I'm running it as an administrator here, and this is just, best practice is to run as an administrator, but also run as a regular user, just in case there's any privilege escalation. Just sort of running it here to make things simple, make sure it has access to everything it needs. All right, so the first thing you'll notice is on the right, Process Explorer lit up purple. That just means the process just started. If you look at the DLLs or the handles, there's not really anything there of interest. Just sort of the basic things that processes keep open. And the same thing with the DLLs. There's basic DLLs that a lot of userland processes tend to use. If you look at TCP view, there are no processes here connecting out to the internet. So at least at this point, it's not doing any internet traffic that we should be aware of. We might double check on that later, but it's good to know at least at the start. So the first thing we're going to do here is we're going to right click on the malware process in Process Explorer. We hit properties, and we're just going to look at some of the process properties here that might be important. The first is image. So the image group, one, it'll suggest whether or not it thinks the binary is packed, and it'll also show you the path that this process is executing from. So this is just to verify that what's running is actually what we have on disk, or at least from the same location. We'll take a look at the strings window. There are two options. There is image and memory. What image is going to do is show you all the strings that reside in the binary while it sits on disk. So you'll see a lot of this sort of garbage here, and that's normal. It's just because the way strings work is it tries to convert every single hex code into an ASCII character and then display it if it gets a large enough run of strings. So in most malware, most software, you'll see sort of this stuff. But basically what we're looking for is some human readable stuff that might be of interest. So domain names, like I said before, something like an author tag. You'll see API names, anything that could possibly be interesting. So here you have this weird K-lock. It looks like half of a string. You see that weird kernel 32 thing and sort of the beginning and get environment there. You scroll down, you've got load library and get proc address. I don't really want to get into API calls too in depth, but basically in malware, if you only see load library and get proc address, it means it's trying to hide some functionality, because these two functions allow it to load any other capability it needs. So if you only see these two, just basically what they're doing is just trying to make it a little bit harder for you to figure out what's going on using static analysis, especially by doing something as simple as looking at the strings. The second option is memory. So the memory option will show you all the strings that reside in the actual process address space while it's running. So while the malware is executing, it might have some encrypted strings and such that it will decrypt and save in memory so it can refer to while it's executing. So looking at the memory strings will allow us to see those things that we may not necessarily have been able to see just looking at the strings on disk. So you see right away we have some just error messages. These are standard compiler error messages. We have the actual type of runtime it's using. So this right away lets you know that it was probably written using C++. It used a Microsoft compiler. These are sort of important metadata points for correlation. You've got DLLs, you've got the keylogger.txt, which is a file path that's probably going to use. You have the current working directory that it's running from, and then you see past that, we start seeing a lot of API calls. All right, so here's some API calls you want to pay attention to. Get key state, set Windows hook, map virtual key, get keyboard state, get keyboard layout. These are all API calls that would be associated with a keyboard logger. Now, granted, just because you see them in the strings doesn't necessarily mean that the malware is using it, but chances are it's doing some keyboard logging just from seeing these strings in the malware. If we did something like look at the PE headers and stuff, we might be able to verify PE headers of the processor. Sorry, if you looked at the import address table of the processor or something, you might be able to look at that a little bit better to really verify or look at the code. But for now, this is good enough to point us in the right direction, even if it's not definitive. So at this point, given these API calls, I'm going to go ahead and look at Process Monitor to see if I see if I see a particular file handle. That's just checking TCP view again to make sure there's no network traffic. But I'm going to look at Process Monitor to check for basically if it is doing keyboard logging, it needs to be writing the information out somewhere. So I'm going to look for some extraneous file handles and maybe other things that would be of interest at this point. So you have all these sort of registry, you have this like really dense output going on now. So I'm going to filter it to only include information for the process that I'm interested in. So you hit that little tab there on the left, and you just pick the thing you'd like to filter on. So in this case, I'm going to pick process name, and type in logon.exe because it's the name of our process, and I'm just going to tell it to add that filter to our list, and then apply it to the entire working set. And so you see there, just everything's logon.exe from the start, process start, and then I can start scrolling down, and this is going to be all the activity that Process Monitor related back to logon.exe. Generally speaking, the things after process start, there's a bunch of just regular traffic that just happens whenever a process starts, so you're going to ignore a lot of that. So you don't, these are just sort of regular DLLs and things, so I wouldn't really worry too much about it. You'll see some registry keys as well. You wouldn't necessarily, you want to pay attention to registry keys for persistence mechanisms, but the registry is very complicated, and it's something that really takes some research and practice to really know what to look at. So, I mean, it's not necessarily something you'd be expected to know day one looking at these registry keys, but just, as you analyze more malware and things, you start learning what it is you want to look at and what to look for in regards to the registry. But like I mentioned before, sysinternals has the auto runs tool that you could also run after doing your analysis to check to see if malware sort of installed itself at some of these common locations. So I'm going to go ahead and scroll down through this output a little bit. And you'll see here is this keylogger.txt on our desktop. It does a create file there, which basically means it created and opened a file, and then you can see there's some read and write files, read and write file calls to this file, keylogger.txt. So just one, because of its obvious name, but just also given the API calls we saw previously for the keyboard logging, we're gonna want to sort of test this theory that it's actually doing some logging. So what I'm going to do here is go ahead and open up Notepad and start typing to see if maybe we can cue some activity based on my keystrokes. So if you notice that scroll bar on the right started to jump up, even though the screen didn't move, I'm gonna type some stuff one more time. See if you scroll down. We have actually generated some more activity, so if you pay attention to it, I'm gonna go ahead and type something else. You notice that scroll bar starts to move again, and all the activity is actually associated with that keylogger.txt file. So if I open it up, what you'll see is all the text I've sort of typed during the session. So we have the logon.exe string, which is the filter I used in Process Monitor. Got the Notepad string, which is what I typed in the search bar in Windows to open up Notepad, and then the two malware analysis sentences that I wrote in the original Notepad window. And close all that out. So basically at this point, this is enough information, and I don't know what, this took maybe 10 minutes, to know that this thing is malicious and a keylogger. You don't necessarily need to go any further with this. In the video, later on you can do this. I do run this piece of malware again, and I run it from the Windows directory. When you run it from the Windows directory, it'll actually store this keylogger file in System32. And it's just a little demo to sort of illustrate the point that behavioral analysis isn't exact, right? You can get different control flows, different execution paths, and the malware could react differently depending on where it is. It could also act differently depending on the state. And it's just to sort of show you that this sort of thing can happen. Do we have any questions about this demo?
Haven't seen anything yet.
Okay.
Yeah, the important thing I'll add to your comments here, Jimmy. The important thing that we're trying to do with behavioral analysis is kind of what we call triage sometimes, and that term gets miscommunicated a lot. But you're just trying to do a down and dirty, quick review of what this thing might be and what its intent is, and document that for further analysis later. Where you get into static analysis and somebody's actually diving through the code and reading in the assembly in IDA to be able to, get a more thorough analysis. So when you get really good at this, it could take you maybe 20 minutes to go through a sample. You get real comfortable with these three tools, and maybe Wireshark as well. And then you're going to be adding complexity by throwing in a DNS server that's fake to let the malware think it's really on the internet. To continue your triage. Any questions out there, guys? Are you guys following okay? All right, got a comment that said doing great so far. All right, so we got about 10 minutes left. No questions. Do you want to kind of briefly cover the second one? I don't know if we have enough time.
I'll show the video. I'm not just going to show them the screenshot so they recognize it, but I don't think we're going to have enough time to cover that particular video. Um, I did have one more demo here that, like I said, we'll post on YouTube, but you can just see I already have some tools here set up. And the basic thing here is I'm going to use Wireshark, fake DNS server, and Netcat to analyze some IRC malware. And the IRC malware, I just go through the steps of figuring out um, what kind of, basically looking at the network communications, figuring out what kind of network communications it is, and figuring out what I need to set up so I can capture a good PCAP of this data. Once we figure out that it's actually connecting to an IRC server, I connect to the IRC server and show you sort of how to figure out what kind of commands the malware takes and things like that. It's pretty interesting, and it's the kind of thing that a lot of the steps here, even though you might not see IRC malware that often, a lot of the steps that you take to figure these things out are the same steps you take to figure out other kinds of protocols with malware. So this video will be up on YouTube or private download or whatever, so feel free to take a look. And I think I just have one more slide, I think, with our courses here that I'll show. Get back into that. All right, so at ANRC, I help to teach and develop these courses that have to do with malware. So if you're really interested in this work, we have a pretty comprehensive curriculum that starts with the behavioral malware analysis piece, where you don't need to know assembly. You can still learn the basics of triage analysis and things like that. And then if you want to learn more advanced stuff, we move on to assembly for reverse engineers, an introduction to malware analysis, as well as advanced malware reverse engineering. So you go from learning assembly all the way to using IDA Pro, writing IDA scripts and things like that. And then we also have a course, sort of tangentially related course called Hacking with Python, where you learn how to use Python to facilitate a lot of different types of analysis. And all these courses are on our website. And yeah, thanks for logging in. And if you have any questions, please let me know or let Nathan know. Be happy to answer them.
Yeah. All right. No questions so far. So thanks. It was great information, Jimmy. I hope everybody enjoyed the conference here, or the webinar. So again, we'll be emailing you with these links to get to the slides, as well as this recorded broadcast. And then we'll also send you in that same email links to the demos that Jimmy's already pre-recorded. So there's a talk track on there. So we would definitely recommend that you follow up with that, because you can take your time and review the videos where he's talking through every little detail of going through both pieces of malware. And that's good to follow as well, because we get into more depth. And like I said, if you want to see kind of more of a series into this, I mean, this topic that he covered was an hour, but there's a whole 5-day course around this. So if you were to attend the public basic malware analysis, behavioral malware analysis course, you're going to be sitting in front of a piece of malware on day one, and we're just going to progressively go through harder and harder malware samples to get you real world experience. It's 70% hands-on, so you're spending a lot of time in our custom laptops that are made for you. And we're going to do that online too. So there's an environment that we've built that you can do the malware analysis through a browser, so you don't have to worry about infecting your home network or your work network. So that's available too. I've got a couple of questions here. One person asked, would you say that malware is a growth industry area? And I'll answer, and I'll let Jimmy answer too. I'd say most definitely. We've seen malware growing out of proportion for the last 3 or 4 years, and it's going nowhere but up. There's just too much money to be made. When you start talking about nation states and things like that, they're utilizing malware to get into government systems. They're using malware to get into SCADA systems. So it's also a net warfare kind of situation, which is causing some concern in our governments. Jimmy, what did you like to add?
Just me. It took me, the very first slide where I had the sort of little media headlines. I mean, it took me maybe 5 minutes to find that stuff. I mean, if you just type malware in Google News, I mean, you just get there's tons of information on the latest malware attacks. I always joke with my coworkers that if this defensive thing doesn't work out, I'm just going to move to some foreign country and do the opposite way, because it's such an easy industry, and in certain Eastern European countries and things, I mean, this is an actual business. I mean, they have employees that work on, creating crimeware and things like this. So, yeah, it's definitely a growing underground industry.
Yeah. Another question, are you guys going to send out info about turning this into a series? Yes, most definitely. So you're going to get a 3-question survey at the end when we close out. Please respond to the survey. Let us know how we did, and also include in your comments section that you would like to be interested to receive the malware series webinar information when we get it ready.
Yeah, and also to add to that, in your comments, if you do you're really interested in doing this sort of web series kinds of things, if you do know, go ahead and put some suggestions of the sorts of topics you'd like covered. Because this was kind of an overview, if there are specific things just from this presentation that you'd like us to focus on, go ahead and list that so that we have some suggestions, to follow up with.
Another couple of questions here. Any advice on how to get interesting samples? Yeah, definitely. It used to be offensivecomputing.net. I don't think they have that anymore. Do you have some good repositories that you recommend?
Yeah, yeah, offensive computing, I think that came back online though. I think you can still use it. There's also virus share. I tend to use that one. You need an invite, but if you contact any forensics analysts, they tend to have that. Also, so here in this references slide, if y'all can see that, some of these books will also include malware that you can look at. Sometimes I've noticed that The Guardian, which I believe is a UK newspaper, so like when Region popped and some other malware samples, The Guardian actually had a link to the malware samples for you to download. So it just takes some looking around, but generally virus share and offensive computing tends to be my go-to. And there's one more. It's like, but malware.lu, I think you can get malware from, and I think if you some kind of subscription, I think with VirusTotal too, you can get access to certain hashes and things.
And final question for a person that's coming from a QA background, is there a good path to transition into malware analysis? And I can speak directly to that, Tim. So I used to be in software quality assurance way back in the day, 2001, I think it was. And so yeah, that's exactly what I did. So my path, if you, at least from my personal perspective, was that I went and got a computer science degree, which isn't required to do this. And then I started getting smart on Process Explorer. I started looking at tutorials online. There's a ton of Tuts for You is one of them that you can go and kind of watch similar. Yeah. And the repositories will get you the malware to practice on and play with, setting up your environment. So it's definitely part of quality assurance, because you're looking at other people's software, right? You're reviewing third-party tools, and it's nice to be able to check that stuff and verify that, okay, this author, it came from a foreign binary. We're going to introduce it into our network, so we need to check to make sure that there's no hidden technology code in here that's mining data and things like that. So other than that, that's what I would suggest. Get real smart on Process Explorer and all the sysinternals tools. And
yeah, that's a. I'd also add, this is just sort of my opinion on it, just from dealing with other analysts and sort of looking at other people's processes, as sort of another tack you could take on that. You've got two different mindsets. You've got the people that will look at the tools and the tutorials and just kind of learn from there, and then you have people that will approach it from a sort of different perspective. So it really depends on what works better for you. But one of the things I always recommend is learn how to program. Learn how to program C, compile your own code, and then open it up in a disassembler and things and start looking at the assembly. Maybe you want to do that after you do the behavioral malware analysis, but I actually got started with assembly that way. So I actually learned the behavioral piece after I already knew how to after I already knew how to read assembly. So, either way works, but definitely learn how to program and learn how programming languages work. And that really helps you when you're reverse engineering things.
yeah, I'll second that. And if you don't want to do the whole C++ path, then Python is an incredibly easy scripting language to learn. Even though you can't really reverse it, you can convert Python code into EXEs and then reverse that. So just general programming knowledge is a good thing to have, because you start understanding things like system calls and calling functions that are part of libraries. and you understand that mechanism. Plus, when you look at it in a disassembler or a debugger, you understand what's going on, right? That's not user code, or that's not author's code. That's standard operating system functionality that you can utilize in your code. And it helps you become a better malware analyst, because you can kind of weed out, okay, that's standard Microsoft code. I don't need to look at that, right? That's not malware code. That's part of the operating system. This part here, this is what the malware author wrote, right? So I need to focus my attention into that. So
Yeah, so regarding this question, I actually have here a list of books and things. These are all books I own or books that I've read at some point in time, that you can use if you really want to have some references on learning this stuff. I'd really like to point out the Practical Malware Analysis by Sikorsky and Hong, and also the Practical Reverse Engineering if you're interested in ARM reverse engineering. They're going to provide you with samples, and Practical Malware Analysis especially is going to provide you with sort of starting at the basics and going to more advanced stuff too, if you kind of want to on your own kind of thing, to look at, or just good reference material to look at while you're trying to learn things from different tutorials online and stuff like that.
yeah. Yep, with that, we'll close out. I appreciate your time today, guys. Let us know if we can help you out further, and look forward to sending you the email for the videos and stuff.